Are you a white middle-aged man looking to worry about something else in your life? Because if you do, I got you. I have a new thing you should worry about. And it's because you're its main target. Not actually, you're just highest at risk. It's Tropheryma whipplei. I'm so sorry if I'm mispronouncing that. I couldn't figure out what it was pronounced like, but I will be talking about this pathogen. Look at that fun bacilli. This is what we'll be going over. Also on the left, this is a duodenal biopsy that I'm not going to show you, but it's showing you the pathogen. Anyway, here's the contents. We're going to go over the classification overview, how she's not like other girls, she's a little different, she's a little groovy. The pathophysiology, proliferation and damage, diagnosis, treatment, and then I'll just show you my references really quickly. Yeah. It's gram-positive and rod-shaped. Remember, it's got a thick peptidoglycan layer and bacilli. It's got a circular genome of about 930,000 base pairs. On the far left, we can see where it falls into the different class, family, genus, and whatnot. Obviously, the bacteria domain and the Actinobacteria phylum and class, Actinomycetes order, and I've been practicing Cellulomonodaceae family. And I'm pretty sure it's Tropheryma genus. But yeah, hope you guys like that little figure for you. It results in classical Whipple's disease, which will be the focus of this talk. Chronic localized infections and acute infections. I didn't want to make it too long, otherwise this would be like 20 minutes. So we're going to keep it a little short, only going with classical. It was actually first isolated in 2000 ad Dominus. I think it's ad Dominus. AD. It was 25 years ago. But I thought it was interesting to know. I thought it was cool. They first cultured it. Pretty fun. I wish I was alive then. So, she's not like other girls. She has a trilamellar cell wall ultrastructure. And this one in particular lacks polysaccharide. I can never pronounce it all the time. Trilamellar has 3 distinct layers. So it's different than other bacteria you might have heard of, and this one in particular does not have a polysaccharide. And this is a feature shared by the macrophage plasma membrane. Little fun fact for you. And then this is the only species within the genus. It doesn't have any siblings, it doesn't have any of that. It's a lonely child. It's so lonely. We should get it another. Let's evolve another one. So this bacteria is encountered in soil and water, but it's supposed to be encountered abundantly in the environment. Exactly where? It's still a little unknown. Truth be told, this isn't the most researched bacteria, but I thought it was one of the more interesting ones, so that's why I picked it. So there will be gaps, and I'm sorry about that. Here's some pathophysiology for you. Let's go on the what you can see-ish. The clinical manifestations are caused by infiltration of the various body tissues by T. whipplei. I'm going to go with whipplei, not whipplei. So the patient's immune system incorporates the organisms into tissue macrophages, first affecting the mucosal lining of the small intestine, and then forms lesions within the wall, and they damage the villi. So it's all within that small intestine, and interestingly enough, you actually won't really see these until kind of after you've been infected with it, so it's kind of difficult to track. So that's also why it's not well researched. But let's get into the weeds of it. Let's jump in. So here we have the one diagram I was able to find that showcased what was going on. So current theory is that our fun bacterium is opsonized by Gal3 and interacts with an unknown macrophage receptor for uptake. It then induces M2 polarization associated with the expression of interleukin-16, interferon beta, and HLA-G encoding genes. Interleukin-16 interferes with phagosome maturation and favors bacterial replication. Interleukin-16 also induces the recruitment and differentiation of CD4 expressing cells into tolerogenic cells. Interferon beta induces macrophage apoptosis. Expression of eat me signals promote the phagocytosis of apoptotic cells and contributes to the local immunotolerance. Tolerance is further strengthened by membrane or soluble HLA-G, which regulates expression of TNF. The tumor necrosis factor, which inhibits immune cell activation after engagement of ILT2 or ILT4 and favors the generation of regulatory T cells. That is as far as I could find this go. I wish I was able to make the connection between exactly this and the clinical manifestation in like a figure, but I couldn't find one and I can't make one. So you'll just have to trust me here. That interfering with the interleukins, it's the interleukin. Yeah, it affects right at the small intestine, that lining, and then that's where we get those clinical manifestations. So like I said earlier, white middle-aged men from North America and Western Europe are at the highest risk. There is the possible genetic base of vulnerability. This is under current investigation. There are other possible reasons that people are looking into, but right now this is the most prevailing theory, and that's because we just saw in a study that a majority of the people who had it were white middle-aged men. So we'll see. I'll check back in 10 years and let you guys know. There's about 1 in 2 in 1 million people who are diagnosed with this Whipple's disease per year. So again, it's kind of hard to track when it's so little. And as of 2019, whopping 6 years ago, 1,000 cases were reported. So I think that's total that they've reported in general since it was first cultured in 2000. So really low numbers that we're getting here. And Whipple's disease has a 6-year delay between the first clinical signs and the clinical intestinal signs. And I'll get into a little bit more, but you'll first experience arthritis and arthralgia, which again is joint pain of that sort. And then you get that intestinal stuff that I was referencing with the direct figure I showed you and the interleukin plays and that. Just to reiterate, classical Whipple's disease, it is a rare multi-system inflammatory disease. It interferes with the normal digestion, impairing the breakdown of foods, hampers your body's ability to absorb nutrients such as fats and carbohydrates. And that is the progression as we understand it right now. You will most likely experience some form of arthritis or arthralgia, diarrhea because of the interfering with the body's ability to absorb those nutrients in the small intestine, a fever, and those CNS manifestations. Now, if you guys have heard of anti-TNF therapy, it's anti-arthritis. It will work to help alleviate the arthritis condition. If you actually are on anti-TNF therapy and have Whipple's disease, it will induce an aggressive progression of the disease, including an increased risk of endocarditis. And I thought it was really interesting, and I found no real rationale behind that. If you guys know it, feel free to pop it in the chat down below. I would love to know. But I thought it was interesting that you're trying to fix the primary symptom you're experiencing, which would be arthritis, and then you just double slammed. Now you have endocarditis, which is inflammation of the heart. In case you didn't know, it's one of the layers of the heart. I hope I'm not wrong on that. Anyways, HIV, interestingly enough, because I know we just talked about it the other day, it actually protects against Whipple's disease. They've noticed a resistance towards this pathogen. Really, really odd. Again, no rationale. Too many questions left unanswered. Too many. And then how you diagnose it. We have a really quick screening. I'm not going to give you a timeline, but it's faster than the official one. You just do a quick qPCR. So like a week, because of the current healthcare system in the US, I guess. Maybe it's faster in other countries. But you get a quick qPCR targeting the T. whipplei on non-invasive samples such as stool and saliva. If it is positive, then you go into official diagnosis. And this official diagnosis, you have histological examination using hematoxylin, eosin staining, and periodic acid shaft staining of a duodenal biopsy. Afterwards, you will conduct a Ziehl-Nelson staining to ensure that T. whipplei is T. whipplei, like you are looking at that. The Mycobacterium avium species can also be stained by this periodic acid Schiff staining. So that's why it's important. It's a good measure to differentiate and know that you are diagnosing correctly. And again, this is a picture I showed just a few slides ago. This is the electron micrograph of the Whipple's disease. And you see those black rods? That's the bacilli from the Whipple's disease. I thought it was really interesting. It's an electron microscopy image. So wanted to share that. They're cute little guys. I wish I could pet them. And then lastly, we're going to talk about treatment. Unfortunately, it's not very well developed. We're still stuck with basic-ish antibiotics. The first successful treatment was in 1952 with chloramphenicol. And as you probably have heard, we don't really like to use chloramphenicol anymore because it's not as safe as modern antibiotics like what we're using or have been using since 2014, which is a combination of doxycycline and hydroxychloroquine for 12 to 18 months. And then afterwards, I've understood it is a lifetime treatment with doxycycline. That's crazy. Not that crazy, but I would just personally not play in dirt that I think has this bacterium, because I don't want to have doxycycline running through my system for the rest of my life. Of course, obviously, new developments are being made on the daily, I'm sure, and I'm waiting for them to release a new paper on what other treatments there could be, because I have not found anything past these little antibiotic concoctions. But you're not going to die. Like, whatever antibiotics it might give you, it might not be exactly these, you're not going to die. You're going to be fine. It's if you leave it untreated that you might die from a few different things, like I said earlier. So be cautious of this, I guess. It's pretty rare. And, thanks for listening. This is so embarrassing. I forgot to show my references. I'd like to shout out the Mayo Clinic, eMedicine, Science Direct, and this one paper I based a lot of my work off of. Thanks. Couldn't have done it without you guys.